Welcome to another session, whether you're joining us for the first time today or you've been with us all day for all these sessions. Thank you for joining. We appreciate you being here. The goal of this is education, and this great conversation is going to be about cybersecurity, what that is, what that means, probably what to do, probably not what to do, or what not to do. We'll see. But great conversation here with Tyler Fordham from Dark Wolf Solutions and Chris Hughes from Aquia. So how this works, ask your questions in the chat. They'll watch it. I'll watch it. We'll also have a block of time at the end for some questions. But gentlemen, over to you. The floor is yours.
All right, everybody's seeing this okay?
Yep.
Okay, easy enough. Well, Chris, why don't you kick us off here, being on the fortuitous left side?
Yeah, from left to right. So Chris Hughes here, CISO and co-founder at a company named Aquia, but I've been in the cybersecurity space, largely in the public sector, for almost 20 years. Been in the Air Force, been a federal civilian with the Navy and also the GSA, FedRAMP and TTS teams, and then various industry roles with DoD and federal civilian agencies, and excited to be here with you guys today.
And Tyler Fordham, I lead Dark Wolf Solutions penetration testing team. I come from a background of being a cyberspace intelligence analyst in the Air Force. I've worked both, as a direct full-time military guy doing that stuff, blue team cyber operations as a U.S. contractor, some offensive security efforts in OCONUS situations, and then for the last 4.5 years or so, I've been here with Dark Wolf Solutions as it's grown. So, yeah, between the two of us, I think we should probably be able to answer all your questions, hopefully, if we're doing our jobs right. Well, we'll kick off, I'll lead Chris in here. We've kind of got two core parts of our presentation. Chris is going to talk to you about all of the basics surrounding cybersecurity in federal DevSecOps and go into the entire world of everything that lives there. And then we'll talk a little bit more about my offensive security realm as it pertains to that stuff in the second part of the presentation. So, Chris, over to you, man.
Definitely. So I'm going to give you guys some guidance on, kind of what to do and try to keep you from having people like Tyler exploit your environment, which he's going to touch on after I go through my slides here. We want to talk about cloud native security in our presentation and what's different about that from traditional cyber, on-premise environments, legacy environments that many of us are used to, especially in the federal government, for example, which, is a little bit earlier on in its cloud adoption journey, perhaps, than some other industries. So what I did here is I took the 4 C's of cloud native security. For those, obviously here with the Linux Foundation, you're familiar with Kubernetes, or many of you are familiar with Kubernetes. The 4 C's of cloud native security essentially is your cloud, your cluster, your container, and your code. And that's a way to think about how you operate in a cloud native environment. So your data center, your cloud environment, whether it's an on-prem data center that you own or you're renting or leasing, or even a cloud environment from AWS, Azure, GCP, and so on. And then, of course, you have your Kubernetes clusters, your containers that are running in those clusters, and then ultimately your code that you're deploying onto those clusters. So what changes in the context of cloud native security? There's some fundamental things that are involved here. The first of which I'll touch on another slide here coming up, is the shared responsibility model. So depending on the nature of the service model that you're using, infrastructure as a service, platform as a service, or software as a service, you're going to have different responsibilities as a cloud consumer. And I'll be touching on those more in the next slide here in a moment. Another big paradigm shift that we see is infrastructure as code. We all know the old days where you had to run cable, order equipment, get physical racks set up, get equipment set up in a physical environment. That has changed now with the introduction of infrastructure as code. We have things like AWS CloudFormation, for example, from the cloud provider, or even a vendor agnostic solution like Terraform. And this lets you take your infrastructure and shift to a declarative, declarative type approach of infrastructure, where you can codify all that in a declarative manifest file and then deploy it on demand in a cloud environment very rapidly. There's a lot of benefits to that, but there's a lot of drawbacks and security concerns around that if you do it improperly or incorrectly as well. Another thing about that is that your infrastructure now becomes immutable and repeatable. And what that means is, instead of just having a lot of configuration drift, for example, if you're doing everything declaratively, you can take that and repeat it in different environments, whether it's in the same cloud environment, different, virtual private clouds and so on, or even move across different cloud environments and cloud providers, for example, or even on premise. If you're working in air-gapped environments, which I know we have some air-gap enthusiasts in the crowd here, you can use Kubernetes and things like that and have that declarative, repeatable deployment model, even operating in air-gapped, on-premise environments, for example. Another thing is it's portable. As I just said, you can take it, maybe you're operating in AWS, you want to move it over to Azure or GCP or even on-prem in some nature or shape or fashion, you can do that as well. So next slide. So as I talked about, we have a shared responsibility model when it comes to cloud. We have the cloud service providers or CSPs, and then we have cloud consumers, which is us using the CSP services. And as defined by NIST, I hate to cite NIST publications, but 800-145 is going to lay out what these different service models are for cloud. If you have infrastructure as a service, platform as a service, and software as a service are the three predominant models that you're going to see. And I took this image here from Azure. I think that they do a great job of demonstrating the different kind of levels of responsibility for the cloud consumer and the cloud provider, depending on the service model that you're using. So back in the old days on premise, for example, you were responsible for everything from the physical data center, networking, your host, your physical host, of course, your applications and networking controls and identity and access management and things like that. But that changes when you start to move to IaaS, PaaS, and SaaS. In each of these models, you're going to have different levels of responsibility. For example, in infrastructure as a service, I'm no longer responsible for the physical facility. Think of things like personnel security at the physical facility, maybe fire control, all these safety precautions and security controls associated with that, physical security controls for the facility. Those go out they're kind of not under your purview no longer as a cloud consumer in an IaaS model. And that continues on as you go to PaaS and SaaS. So moving up a little bit from there, in the PaaS model, you may have responsibilities falling on the cloud provider that handle things like the operating system. You're no longer, they're handling some of those responsibilities for you, offering managed services from cloud service providers. And then moving up further up the stack, you have SaaS, where you're not even creating the application. You're essentially just consuming the application. Maybe you have some control over the configurations, settings you can set within the application, but you're not creating the application. You didn't code it yourself. You don't control the underlying operating system. We all know the good old days of applying STIGs and gold images and things like that. If you no longer own the underlying compute environment, you're using SaaS, for example, you're not going to be responsible for those things. The cloud service provider is not responsible. One thing I wanted to emphasize, though, is, despite there being a shared responsibility model, you can't outsource accountability. It's still your data. You still own that data, and you have to be responsible for it for your stakeholders, your customers, and so on. So you can't outsource accountability. So remember that despite any shared responsibility model that you're operating in, you ultimately are accountable for the data that you put in that environment. And that's why you need to be very sure of the cloud service provider, their security controls, their certifications with things I'll touch on in a moment, like FedRAMP and DoD security requirements guide and so on. So next slide, please.
You got it. I'm going to, per a comment in the chat, I'm going to exit here for just a second and shift to full screen mode, which is supposed to be Shift F5, right? Is that any better, Valerio and or chat writ large?
Nope.
It's still showing the same thing.
Interesting. Which side of this are you guys seeing? The
We're seeing your cloud and clusters. I can see both of them right now. I can see both slides.
Yeah, it's showing the primary slide and the subsequent slide that's going to come next.
Interesting. Okay, you know what might be easier here is probably, let's go ahead and just current, from current slide, right?
I was joking with Tyler before we went live here that he can hack into your computer and your network, but PowerPoint, that's another beast.
There we go. How about that, folks? How are we working?
There we go.
There you go. Yeah.
Good job, hacker.
So kind of moving down that paradigm that we talked about of, you have your cloud, your clusters, your container, and your code. So cloud is going to be first up on that list. So I've listed some things here. Where do we start? First off is going to be understand that shared responsibility model. What kind of model are we operating in? And often you're operating in many of these models at once. You may be using some infrastructure as a service, some managed PaaS services, consuming SaaS services for certain use cases and business requirements or mission requirements, things like that. So understanding, what model are we operating in what context context, and what are we responsible for? And that's where things like, certification schemes, if you look at this here, I cite FedRAMP. For anyone familiar with, not familiar with FedRAMP, this is essentially the federal, approach to authorizing cloud services for the federal marketplace. So anything that you're trying to use from a cloud service provider, any cloud service offering should be FedRAMP certified. But that, of course, is a very cumbersome, time-consuming process. It takes hundreds of thousands of dollars, typically 12 to 18 months, and it can be prohibitive for small businesses. So you see a lot of shadow cloud use. I'm just throwing that out there. That's not FedRAMP authorized. But building on that, in the Department of Defense, we have what's called the Security Requirements Guide, SRG. If anyone wants to go take a riveting read through that, that lays out, they often call it as FedRAMP Plus. Cloud service providers will go through FedRAMP, and then from there, they have to go through, the DoD SRG, and DISA, the entity within DoD, will grant a provisional authorization on top of the FedRAMP certification that these cloud service providers can operate in DoD environments. And DoD has different impact levels and different security requirements. You can't see it quite in that slide so well, but if you go look at the document, they have impacts levels 2, 4, and 5, and 6. And each of those different levels had different security requirements associated with them, things around multi-tenancy, citizenship of the staff and personnel with access to the facilities, and things like that. And you can go dig into those requirements depending on the impact level or the environment that you're operating in, and see what those security requirements are. So what do we do when it comes to securing the cloud as we move up this kind of stack of the 4 C's? First off, you want to use things like cloud security posture management tooling. There's some native services from AWS and Azure and GCP that can go and look at your cloud environment and understand how you're aligning from both a security and a compliance perspective. You can see, am I complying with things like NIST 853, for example, or PCI and so on, or HIPAA, and on, as well as, am I aligning with vendor security guidance, AWS security best practices, for example. Using some of those native tools, CSPM tools from the cloud provider, you can see, is my environment aligning with these requirements? Is my cloud environment hardened and secured appropriately? And then, some other recommendations include using things like CIS benchmarks, Center for Internet Security, or DISA STIGs, Security Technical Implementation Guides, and then coupling that with vendor best practices. So when you use the CIS benchmarks, the DISA STIGs, the vendor best practices, you can really get to a more comprehensive approach of securing your cloud environment. And people can go and look and see these benchmarks and STIGs, as well as vendor best practices from the vendor websites themselves. And then, of course, I touched on the DoD SRG and its impact levels. So understanding, where am I deploying my workloads in the cloud? What are the security requirements associated with that? And how do I ensure I'm aligning with those is a critical step of securing the cloud. So moving on from there, let's go up to the next level here. Next up is clusters in that 4C paradigm that I talked about. And of course, there's other things, other ways to orchestrate containers, but Kubernetes has quickly become the de facto container orchestration tool of choice. Anyone, typically deploying containers and orchestrating containers at scale is going to be using Kubernetes. But Kubernetes is a very complex beast. It has a tremendous benefits of providing efficiency, scalability, elasticity, and so on for your cloud native workloads, your containers. But it can easily go sideways when you think about misconfigurations, vulnerable configurations, things like that in your environment. So how do we go about securing our Kubernetes environment? Much like with some of the previous guidance, there's actually guidance out there from DISA in the form of the Kubernetes STIG. There's also a CIS Kubernetes benchmark. And then building on top of that, you're going to have vendor guidance from places like AWS or Azure that show you how to secure their managed Kubernetes offerings, things like Azure AKS from Microsoft Azure, or AWS's EKS, Elastic Kubernetes Service. So using these managed Kubernetes services, for example, they control the control plane. If you think of Kubernetes and two planes, you have your control plane and your data plane, for example. They may control the control plane for you, but you need to understand how that managed service is configured. And you still have peripheral services like identity and access management or logging, things that you need to account for in your cloud environment, for example. And then in building on, DISA STIGs and CIS benchmarks, there's other great guidance out there from organizations like NSA. NSA put out their Kubernetes hardening guidance. I definitely recommend folks check that out. I'm seeing some plugs in the chat from Gerald for things like the Enterprise DevSecOps reference architecture. Definitely check that out if you're working in DoD. It's a great example of how to configure your Kubernetes cluster, how to operate in a Kubernetes paradigm securely. Another great resource there, CNCF has a Cloud Native Security Best Practices white paper, really comprehensive, touches on Kubernetes, containers, and so on. Definitely recommend checking that out as well. So next slide, please. Moving up that stack again, we have the next C is going to be containers. So you have your underlying cloud environment. Maybe you have it secured, it's compliant, you have it set up correctly. You have your clusters in place, you've secured those, you have secure configurations in place. You followed the guidance from the managed service provider in the case of the cloud provider example, or you're using industry best practices from places like NSA and so on. What do I do about my containers? And now you have these immutable, portable things that are really tremendously valuable and can be moved around different environments and help me deploy workloads. They're immutable and all that. But guess what? That immutability, that repeatability, if these things are vulnerable, they have malicious aspects baked into them, all you're doing is kind of rapidly proliferating that across your enterprise at scale. You've just taken it, you went on GitHub and pulled the available containers off of container repository. You have no idea what vulnerabilities are baked in there, what CVEs, what misconfigurations might be in those. This is where you need to start looking at hardening those containers. I wanted to make a plug for Liz Rice. She has a book called Container Security. I found this one several years ago. It's still one of the best resources on the topic. Definitely check out that book. And then you want to start using tooling. What's some of the tools that we can use? There's some great open source software tools that are free of use. You can go out and grab these and start using those. Start scanning your containers, whether they exist in a repository, they're going through a pipeline, or they're even in a runtime environment. There's open source software tools out there to do that. There's vendor proprietary third-party tooling to do this, and start to look for misconfigurations, look for vulnerable components in my containers, for example. And then another key piece is starting with a secure base image. Think of the term attack surface reduction. Containers typically operate in layers, and as you add more and more layers on that and more complexity, you're potentially adding more and more vulnerabilities. If you want to see some tremendous research, I think we have some folks from CanGuard speaking at the event here. They have an awesome white paper out there about the importance of a secure base image. And they went out there and they ran some tests with typical, some of the most popular base images that are used, and then scanned those with tools like Trivy and so on, and start to look at, what is the security posture of these containers, these base images. And you'll be very surprised with the number of vulnerabilities that are baked into these base images that people are just taking and using and building on that and putting their workloads and their code and things like that on those base images and deploying them into production environments. So if you look at here, there's some studies out there from groups like Palo Alto's Unit 42 Threat Research Group. They showed that almost 100% of publicly available containers have either critical or high vulnerabilities baked into them. As soon as you take them, they're already vulnerable, and you put it in your environment, you're running in a production environment. So definitely want to give a plug here. I think DoD has done some really innovative things. If you look at things like Iron Bank, for example, from DoD's Platform One, a great example that actually got picked up by industry and cited by groups like CNCF and others, is you want to start using, hardened, signed, trusted images. You understand, what's in this image? What's the security footprint of this? What's the posture of it? Vulnerabilities associated with it? Is it signed? Do I know where it's coming from? Understanding that provenance of the container is critical as well. And I want to emphasize, not just scanning the container in a repository or during the pipeline process, for example, but scanning it in a runtime environment as well. Maybe a vulnerability didn't exist at the time you scanned it in the pipeline and it's been running in production. But the thing is like, as we all know, software ages like milk. New vulnerabilities have emerged, new CVEs. Maybe now you have vulnerabilities in a runtime environment that didn't exist previously. So you need to account for that and essentially remediate those, rip out the old containers and essentially replace them with new hardened images that you've addressed the vulnerabilities in. Another thing is being aware of secrets. There's a lot of situations where you have secret sprawl. I think of things like API tokens, cloud native access tokens, API keys, and so on, usernames and passwords, and the list goes on. You have developers kind of committing these things to container images and repositories and so on. If malicious actors stumble upon this, they can do a lot of tremendous activities with these to impact you, your organization, or other systems and organizations you connect with as well. So you need to be using things like Trufflehog and others to identify secrets that may be baked into those container images and pushed to a production runtime environment or living in a repository and things like that. Ultimately, you want to also produce what's called an SBOM, or software bill of materials. Gerald is right on top of the links in the chat here. He dropped a link to the executive order, which calls for SBOMs. We've now seen subsequent guidance from both DoD and the federal executive, civilian executive branch agencies. When it comes to producing SBOMs, we're seeing a lot of tremendous activity out of groups like Linux Foundation with SPDX, Cyclone or SPDX, the SBOM format, as well as Cyclone DX from the OWASP Foundation. And these two leading SBOM formats are allowing organizations to go out there and start to produce SBOMs for their containers. They can understand, what components are in these containers, and are there vulnerabilities associated with them? Then you can start to understand, where the components come from, what project the maintainers are for, what the project maintainers look like, where are they from, how's their mean time to remediation. You can get a lot of visibility on those software components in the containers by producing an SBOM. And I put a plug here for SIFT, which is an open source software tool from the organization Anchor. Is a really great tool to check out for producing SBOMs for containers, for example. Next slide. So last up here, we have our code. So, you have your underlying cloud environment. Maybe that's hardened and secured. It's compliant. You've, met your compliance requirements. You have your clusters configured correctly and running appropriately. You have your containers now are hardened, and you're trying to deploy code into these runtime environments that are, using the containers, using the clusters, using the cloud. And it runs on top of all those. So you got to have that secure foundation in place, but ultimately you're trying to put code out there to run, mission or business applications and provide value to your stakeholders, your customers, and so on. So what do we do on this front? This is where you want to start to use AppSec best practices or application security best practices, using things like SAST and DAST, which is scanning your code, both in a static state or a dynamic running state, identifying vulnerabilities associated with the code. And I put a little image here. Actually, if you look at the DevSecOps reference architecture that Gerald cited in the chat there, this image is actually from that document. So you can go check that out. It brings this image up. And I think it does a great job of showing the entire life cycle from dev, to operations, essentially all the things you want to account for, whether it's auditing or patching or monitoring and on and on. So definitely check out that document. And then you want to use other techniques like secure code review, have peers review code, look for, vulnerabilities in the code or poor coding practices, insecure coding practices. And then you also want to do threat modeling, understand what's the application, what's the use case, how can we think about how malicious actors or threat actors are going to try to compromise this application, and what can we do to try to remediate that before it gets to a runtime production environment and could be compromised, for example. That's another thing you want to take advantage of. And there's some great guidance out there around threat modeling from groups like OWASP. And then secure code review, Linux Foundation actually has an organization associated with it called OpenSSF. And if you go take a look, they have an OpenSSF secure coding course that's free, as I understand it, for people to go check out as part of the broader OpenSSF open source software security mobilization plan. Is providing that course out there to the developer community and providing those resources. So definitely check that out. And then moving on from there, maybe you have your application deployed, you have your cloud, your clusters, your code, your containers all running in a production environment. That's where folks like Tyler are going to come in and start to penetration test or pen test your environment, your application. So I want to let Tyler take it over from there.
Thanks a ton, Chris. So we'll move on. And I know we have a couple of questions in the chat. I think that the best way to address this will be after. So let me get by here, talk to you a little bit about hacking, and I promise that we'll get to everybody asking non-milk related questions in the near future. Chris shared with you guys a bunch of information about kind of how this sector works as a whole, right? Focusing on DevSecOps in the cloud, containerization, and all of the software tooling practices and whatnot that goes around it, is very important. But as Chris alluded to, right, you can have every defense in the world, and there are still going to be ways for incredibly clever people to find something wrong with what you built. So that's what we're going to talk about and focus on here. Pen testing in a modern DevSecOps environment. It's a bit of an interesting time, and we'll talk about some of this in following slides, but it ends up being a very different, particularly in the federal sector, experience than you would normally think of a hacker and the actions that they would be taking. It looks significantly different. And in particular, something I'll lead off with, because I have to, since we've already brought up NIST and authorizations, is that really pen testing ends up being one of the final quality checking tools that the DevSecOps process writ large has in the federal government to really get software off of the ground, authorized and approved, right? So you think about all the things that Chris talked to you about. We have a secure cloud, a platform built around the software, an orchestrator that's throwing it around everywhere, and pipelines that are scanning and checking the code that you're developing and running through those in perpetuity. But as a step before things can often get deployed in a warfighter environment, right, where we need to have a high level of fidelity from many authorizing officials that it is truly good to go, it's not going to present risk, and they're comfortable with it, pen testing ends up being that final line of defense. So there are a couple of different avenues in which that is used, right? You have traditional authorizations where, and these match oftentimes the more traditional waterfall software development cycle, but traditional authorizations are still often used for modern applications and even factories where software is built at a point in time, and then folks like myself and my team will go test it in the same way that a hacker would, whether it's looking at the infrastructure, the application, the underlying source code, the APIs, hardware attached to it, or anything in between. It comes back clean or relatively clean, and that ends up being the final go that it needs to get approved, right? You have fast track ATO, which is an interesting thing, not dissimilar from what I just described, but effectively alongside having a lot of the positive practices that Chris just described and having a pen test coming back relatively clean, you can end up bypassing the slow nature of what a traditional authorization would be in terms of the arduous process that can sometimes be a full roster of NIST 853 controls or similar regulating bodies. And then continuous ATO, and we're going to talk about this a little bit here, which is effectively the model that was popularized way back in the day with the Air Force's first software factory, Kessel Run, where the idea is if everything that Chris described is in place, you are testing all of your software, your people are awesome, you have the right culture, and you're doing everything correctly, I can, as a military decision maker, authorize your organization and its factory. And so that everything that comes out of that, to an extent, and with reauthorization needed at various points in time, is automatically authorized. And pen testing, of course, is a big part of that too. So let's talk a little bit more about why and where this actually fits in before we get into the fun stuff. So there are two main models of how this kind of stuff works: pen testing, software applications, and capabilities that come out of these DevSecOps environments. You have one-off tests. Let's say that you have just deployed an application. Maybe it's a mobile front-end web application. It's got a few APIs. It's not tied into a giant organization, and maybe you're not a factory that's building things constantly, but rather this is kind of the marquee thing that your organization has created. One-off penetration tests are oftentimes used for things like that, or getting, for example, cloud infrastructure deployed and making sure that the configuration, the deployment, and everything surrounding that is secure. Heck, we've even seen these one-off tests being applied to continuous things just in kind of an ongoing basis. Things like, ethereal Kubernetes deployments and the latter. And then also a very common model that you'll have, particularly within the Air Force, but I think increasingly so in the federal sector, is when you have these organizations doing all of the things that Chris talked about, right? Building software in the same way that you might expect a commercial organization to, they will often have full-time in-house red teams where everything they're building, from their infrastructure, their platform, the software that's getting pushed out, and I mean, maybe even getting into the realm of doing things like testing facilities and sending phishing emails, they have on-staff penetration testers, hackers, looking at everything that they do all day. So both have their time and place. And in fact, it's best when you do both. But depending either way, whichever model you're going with, there are a couple different ways to look at it. And there are some specific considerations when you think about this from a modern DevSecOps cybersecurity perspective when I describe these three terms to you, right? So there's black box penetration testing, where someone would go in with effectively no knowledge, and an organization is seeking to figure out what a total outsider might be able to do to their application. This is the kind of scenario where folks will often be hammering against web front ends, looking for publicly exposed IPs, doing open source intelligence research, and basically coming from the same place that a foreign state hacker that doesn't have existing access might. What's particularly interesting about this, based on testing in a DevSecOps environment, is black box testing can be, I would offer, incredibly fruitful, or oftentimes, when things are set up well, incredibly boring. in a scenario where, and Chris went over some of this, where things like Kubernetes endpoints are exposed, AWS or Azure routing rules are not set up well, these can end up being a very fun time where folks are able to get access to things that they never should have been able to see in the first place without a VPN. Otherwise, if all of that stuff is really well locked down, oftentimes there isn't much to find other than, basic information confirming I couldn't access things and researching individuals associated with an organization, which would oftentimes then lead you to what is the white box portion of penetration testing. So in the case of DevSecOps and the environments we're talking about here in the federal space, what a white box penetration test often ends up looking like is testers will get full access to everything that an organization is deploying, hosting, running, etc. Generally, what that would mean is that I want to get into your cloud environment. You need to give me a security audit IAM role in AWS. Get me basic creds to your major applications. Show me network diagrams. Tell me about the applications that you're deploying. Show me the ones that are closest to production so we can do basic testing against those. And effectively, right, we're coming at that from the perspective of somebody who lives within the organization. An insider is the closest, or assumed access is what white box testing comes from. So obviously, right, you get totally different value sets, particularly in these wildly separated, either you're in or you're out, oftentimes, cloud deployed modern DevOps environments. So for that reason, the thing that we often see, and my personal very heartfelt opinion, is that gray box testing, which is a combination of both of those strategies, is oftentimes the most valuable thing for an organization. Why wouldn't people always do gray box testing? Maybe not everything is set up and you're just getting your basic perimeter set up, and you would use black box testing at that point to determine what your cloud boundaries look like before you start throwing things in. Maybe only white box testing if you're absolutely certain that your outside perimeter is locked down, but you are concerned about what employees or folks with assumed access might do. And also maybe cost and time are also factors, in terms of limiting it to just kind of one of those approaches. But let's move on and talk about a couple of other things. So I've mentioned this a little bit, but let me hammer this home for people who are not really familiar with penetration testing, offensive security, and that realm as a whole. Testing things in the cloud, in DevOps environments, and really just programming heavy places is an entirely different experience by and large than your traditional pen testing is. For example, just keeping it to federal sector, when we think of your traditional pen testing, what you might have expected in organizations like the Air Force, Navy, federal or organizations, what have you, 10 years ago, would be testers go in. It's going to largely be Windows deployed networks. There might be some Linux servers hiding around, but effectively everything is going to be on premises. Moving laterally through those environments, a huge focus on attacking Windows was the thing. Homegrown web applications were really far less common of a thing. And the ones that you would find would be archaic applications built by large contractors. I'm sure many of us in this audience have used those kind of things during our exposure to the federal sector. So really, it just looked like an entirely different thing, right? We would be trying to find outdated systems, abuse known CVEs, going against jank applications at times that were kind of built in the classic waterfall style. And there were, honestly, in many ways, a lot of gimmies and gotchas that you could abuse as a pen tester. Nowadays, people like Chris and everybody doing the things that he's talking about are following frameworks that prevent a lot of that low-hanging fruit from being there in the first place. Now, I won't say that's universally the case, as we'll go over in some of the examples that we're going to talk about here, but generally, it's an entirely different world. These skill sets that are required for somebody trying to test, offensively these kind of environments is one where you can't really get by without competent programming skills. You better know what DevOps are. You need to have exposure to cloud environments, period. If you've never touched AWS, Azure, or GCP, you might be the best on-premises pen tester of all time. But you're going to be fumbling around figuring out what the services are, how IAM roles interact with each other, understanding what tooling to use, and everything in between. So what's interesting is, from my perspective as somebody who tests and hires a lot of penetration testers, the first things I ask, because we live so much in this world, are, what's your exposure to DevOps? What's your exposure to cloud? Tell me about the languages that you code in. And it's interesting because those are incredibly important. You can learn them, but boy, are you at a disadvantage if you don't come into the industry knowing those things. And that's part of the reason why this is an interesting field in general, trying to find the skill sets, because by virtue of the fact that most of the businesses, I think, in this chat are still hiring a lot, they're not all out there. All that to say, right, let's touch a couple other things here. There are significant differences between, honestly, how you operate. Let's not even talk about hacking, the various cloud providers, AWS, Azure, GCP, even thinking about the things like OCI. And then you have the various flavors of those things that live in the government spaces. All of you Cloud One folks in the audience, can I get a what? And it means that the world around you is constantly changing as you look to try and break, destroy, and hack these things. There's also an interesting scenario where there is, to the point that Chris showed, there is tons of tooling that can give you examples of why your code is bad, what you need to fix, code smells, static code analyzers, dynamic code analyzers, binary checkers, and those are all great. And then alongside those, you have many of the standard auditing tools, that you would use in a traditional sense in the DoD, but none of those constitute pen testing, right? Because you can find, and sometimes, pen testers will use those tools, but ultimately you are attacking an application, a capability, software, an environment, or a system in an entirely separate and dynamic way than many of those tools represent. We're going to talk about this a little more in a slide to come, but the ultimate reality is not everything gets found by those tools. It can't. You can't automate security to 100%. And that's part of why pen testing is a really interesting tool to basically be able to help validate and grow much of that software, right? The things that tools like Twistlock, SonarQube, Sneak all miss when we are looking at applications are things that can go directly back to organizations deploying them to better harden what they are looking at in terms of their software for the next time around. And oftentimes, and we're going to show this off too, those tools themselves present an attack surface. Maybe you're just deploying an application and you think that that's all you have to worry about alongside the infrastructure, but no, if you let all of these DevOps tools sit in your environment and you don't update them, I tell you, they've got CVEs too. And in fact, they're some of the most popular tools for security research in the industry right now. Guess why? Because everybody's using them. Because if you figure out a way to get root access on a box by hacking into Twistlock, you're going to be able to own a lot of DevOps environments. And this is no surprise to anybody who knows anything about Kubernetes or who listened to Chris at all, but the North Star when doing any of this kind of DevSecOps focused pen testing, whether you're in the cloud, even for local deployments, right? The moment that somebody says, I'm deploying a microservices-based application that's orchestrated by Kubernetes, you know what your job is. And it's to get access to and take over Kubernetes. Because once you own the orchestrator, you've won. You own everything. You can do whatever you want. There are some exceptions to that. We'll talk about role bindings and such. But, Kubernetes is, it's a lot of fun when you can successfully take over the orchestrator. So with all of that being said, let's go over a couple of examples here. What I'm going to be showing you are redacted examples of actual findings that we have had related to DevOps environments in the federal sector. I'll talk to you a little bit about each. It's entirely possible that some of you in the audience could recognize images here. I would bet that a significant plurality of you might even deeply recognize this user interface right here. But drop many questions my way and let's look into these. So right? We already talked about, and fortunately, I automatically tied back to each of these things. Having tools in your environment, even if they're meant to provide security, they can often be a security flaw themselves. So in this instance, feel free to drop a React or something in the chat if you've used OWASP Zap. If you haven't, it is often baked. It is not only a pen testing tool when used in a vacuum like that, but OWASP tooling can often be baked into security pipelines to help identify outdated binaries. It's a great tool to have. It makes sure that your SSH isn't 5 years out of date, but it has a user interface that you can log into like everything else. And if you set it up wrong, you're going to have a bad time. In one such case here, when we were working with the government software factory, the OWASP Zap instantiation, fortunately required authentication. And so our guys went darn until they noticed that even in the unauthenticated page, you were still able to upload tool configurations. So what that meant for them was, shoot, I can just totally recreate the application configuration to give myself an administrative user. So they did precisely that. Once they were in the application with all of the built-in programming functionality, they were able to use that to end up creating direct system calls. You can see the highlighted Linux and IPs and everything down there, private, by the way. And through that, we're able to get full remote access on the underlying host. If this sounds like mumbo jumbo to anybody, the long story short that I want to tell you is if you can go from a web application of any sort to getting access to the underlying system, if that was not explicitly intended, means that a very significant vulnerability was exploited. That's always going to be something that's akin to high or above. Remote code execution, or RCE, commit that one to memory. Yes, hold my beer indeed. That line is often used when you get these kind of wins or realize the kind of win you're about to be able to get. Yeah, and to Rob's point there, I'll go ahead and answer this directly, right? That is never the kind of thing that you're going to be able to find with Nessus scanning, scanning binaries on hosts. And honestly, those are not the jobs of many of these DevOps tools to find. Something has to be able to detect the human error, and humans are really good at calling each other out. So here's another interesting example. We've talked about code scanners not being able to get everything. I promise you that's the case. And here's a really fun example of that. When you think of the applications the DoD is building, you might not have the greatest faith in some of the tools that you've used on the Air Force portal, but there are probably some less developed applications in the federal sector, right? But the assumption might be that but commercial apps in general are going to have far better security. They have teams, that are responsible for this stuff. I tell you, brother and or sister, everything works the same way. So when we look at the applications that come out of these software scanning pipelines, whether they are homegrown in the DoD, commercial, or some weird, unique mix between, there are always vulnerabilities left, even if they come back completely green, right? In one such example here, where we were working with yet another software factory on an application that was going to be used directly downrange in a warfighter capacity to help them categorize data, classify things, and really was going to have pretty significant, sensitive, and important data in there. This was a commercial application from a well-known security vendor, but we'll keep it at that. Basically, one of our particularly talented testers realized that a certain wizard within this application would spit back out whenever any action was performed, a code that seemed to be not quite random. And through a little bit of reverse engineering in the source code that we were provided, determined that if you sent a request that reversed that code, basically asking for what it did, you would get the exact system calls that were made when that web application request was being sent. Upon doing so, he had the bright idea to basically reverse engineer that process further to the point where we developed PowerShell scripting that would make system calls directly into the application, got a reverse shell, which in hacker lingo for everybody basically means that we set up a separate system to listen to an incoming request from that system, and got backend administrator level access to the system that is deployed with, or to the host rather, that is deployed with this major application. Plenty of examples of these kind of things. This was a CVE level finding, though I think due to the sensitivity was not submitted as one. And, you know, it goes to show that, right, it doesn't matter where it comes from. Pen testers will likely always be able to find issues with something, even if every automated tool in the world said that it was good to go. Similarly, Chris really set me up well to talk about each of these three things, because accidentally his slides kind of corresponded with each of mine. And I'll just brush over this slightly in spite of the X-Men references. But if your Kubernetes orchestration, if every part of it is not set up really well, it presents an enormous attack surface for hackers. In general, right? If you are home rolling your own version of Kubernetes and you are not using the STIG guidance, or please at least the CIS benchmarks, you are going to have exposed endpoints. You are going to have roles that are deeply screwed up and give certain people way more access than they should have. Role-based access control, shout out to that critical principle. And these are the kind of things we see all the time. Not only, really, to be honest, in just home-rolled baby's first Kubernetes, orchestrations, but, we will even commonly find in more commercial, large-scale Kubernetes orchestrations, I won't name vendors in specific, I love you guys, that there are issues in terms of overexposure of assets, roles being, screwed up in terms of accesses that somebody should or shouldn't have. And, honestly, things like blob and cluster permissions, which need to be as locked down as possible. Quite honestly, if you're able to get in at all, it turns in 5 minutes left. That's so perfect, Matt. I'll hurry up. If you're able to get in at all, you start to get into the level of container security testing, which Chris talked on a little bit more, where honestly, if you haven't used many of the tools that he talked about to basically trim down the containers that live inside of your orchestration, then there are so many basic tools in a normal Linux box that can be used to get somebody creative access in a way that wasn't intended. So I will move on for the sake of time, but Kubernetes is not secure by default, I promise. Look at some of these tools and run them against your clusters if you've got them deployed. So there are some fun examples. I'd love to bring Chris back in here and we can talk just a little bit, right? But at the end of the day, when we're looking at the federal sector here and everything that we are deploying in organizations like the Air Force and beyond, it is all of those initial considerations, building things securely, following and creating these standards, plus testing the hell out of them to make sure that they're working, that results in us being able to create this empire of secure software that we've been building the last few years. Anything else you want to tie in there, Chris?
I don't think so. I think you wrapped it up pretty well. I'm looking, actually, Matt asked us if we addressed the Q&A, so I'm looking to see if there's some Q&A in here. Let's see.
You got it. We'll run to the Q&A and maybe we can each get 10 seconds to talk about our companies before they kick us out.
Tyler, I might give you 11, Tyler. Okay,
awesome. Thank you so much. I'll read these off and let's see if we can take stabs here, Chris. Douglas Kokok, my cloud is entirely contained within the hull of a submarine. All of the hardware is inside the hull, and we run containers on it using Kubernetes. A lot of what you said about cybersecurity seems to not apply. Is that correct? What are the important things I need to think about? I'll kick off and say initially, from my perspective, that's all well and great, but if you have sailors on the ship, all it takes is one capable, malicious, or unintentional, person plugging the wrong device in, to anything near that hole, anything that has access to the cluster, and you could have malicious logic designed to remotely exploit something like that without any interaction.
Yeah, I think that was greatly put. And obviously, like the 4 Cs of cloud native security wouldn't be applicable and to some degree, you know, if you're running in an environment like a submarine. But as you point out, there's still exploitability, there's still attack surface to be considered in that scenario too.
Yeah, big time.
And that said, a little plug, I know there's some people out there doing innovative work to deploy Kubernetes and things like that in the submarine community. So shout out to them too.
Yeah, we want to get on more of your subs, I promise. So please hit us up. Rob asked, the word scan a container. Can you describe what that means and how that might be different than scanning source code? I think this is a good one for you to QB, Chris.
Yeah, I mean, this is touching on the slide I had about, you know, the 4 Cs where I had containers and code separated. You know, when I meant container, I'm referring to the container manifest, for example, not necessarily the source code that you're looking to deploy on top of it as an application, you know, or workload that you've written or using third-party open source software components for example, and using some of the tooling that I talked about, you know, in the slide that I had up there, whether it's vendor proprietary tooling or open source software tooling that you use to scan your containers and your code, as he talked about with OWASP projects and so on. The last one there, I'll take this one if you don't mind.
Yeah,
Valerio asked, he said, the supply chain defense landscape is particularly active and evolving nowadays. Is there any platform SaaS or open source project that covers software bill of material or vulnerability exploitability exchange lifecycle management other than the excellent work of Steve Springett and the dependency track? The answer is yes and no. Obviously, Steve Springett, being the creator of dependency track and Cyclone DX, the SBOM standard, is way ahead of many in the industry, but there's a lot of investment and effort rushing into this problem space as well. There's some other groups doing things. There's a group called StackAware from Walter Haydock, who's looking to tackle this problem. There's other groups. I actually just interviewed someone from Endor Labs, who's looking to address this kind of a challenge as well. It's an evolving space with a lot of investment and a lot of intention that's going to continue to grow.
Yeah. Well put. I'll pop back here so we can get a quick chance for a shout out. If you want to hit him, Chris.
Yeah, just a real quick note on Aquia. As I said, you know, co-founder and CISO at Aquia. We're a member of the Digital Services Coalition, SDVSOB, great place to work certified, and we're focusing on mostly cybersecurity and things, SaaS security, GRC in terms of continuous ATO, doing a lot of AppSec, threat modeling, DevSecOps work in the software factory or PaaS space. Over to you.
Thanks, Chris. And Dark Wolf Solutions, I love this place. You know, we do everything from penetration testing, offensive security consulting, development, and everything in between. Have a lot of really interesting clients that we work for in the federal government, as you can see at the bottom. One of the things we love to do the most is go to all of the major hacking competitions and bring back wins. So we were actually first in both the naval hacking competition as well as the IoT hacking CTF at DEF CON this year. If you have interest in offensive security or anything else, please hit me up.